Hello, this video is about a theory resulting from a study of the possible effects of relativity and how it may apply to electromagnetic radiation, some near massless particles / waveforms that travel at / close to the speed of light. I personally have never liked the idea that our knowledge of the outcome influences a quantum event, and this has inspired me to look into detail at this ossification from quantum mechanics. The idea is we do not understand, so we have added a ghost to the atom. Assign the concept of choice to a subatomic particle. This appears to be a simple way of masking the unknown. The mathematics alone can scare off anyone who looks into this field. I approach the problem in a pragmatic, logical way of thinking, about the observations of space-time and the events, its relation to relativity. Please watch this video with an open mind. The proposed theory is not 100% complete. I hope it explains some things, and I hope it removes the delayed choice idea, and hopefully it would lead to better understanding and some fairly radical possible uses for this theory. Thank you. Light and all electromagnetic radiation travel in a vacuum at the speed of light, referred to as c. Extending Einstein's theory of relativity, we can predict the time dilation of any moving object. The relative or local time gets slower as the speed increases. The energy required to accelerate something increases because the mass of the object increases the faster it goes. So there is not enough energy in the universe to even produce a small sample of test data from sending equipment to near the speed of light with our current technology, or a way to recover or stop it to see what the results were and to play them back, because you don't have the energy to accelerate it there, and once it gets there you're not going to have the energy to slow it back down again. So you can predict the electromagnetic radiation has a time dilation represented as a decimal, just because it's easier to try and understand. I've created a decimal scale for this, extrapolated from Einstein's theory of general relativity, where 0 is represented by something which has absolute time dilation, and 1 being an object at rest outside of a space-time curve, which can never happen anyway. Even a hydrogen ion would generate its own space-time curve, but so 0 and 1 theoretically being unachievable on this scale. Using this large assumption that electromagnetic radiation has a time dilation of 0 and is a photon or a wave potential, never moves in any of the classic 4 dimensions relative to its own perspective. So, you take the value and add it to some speed equations, it becomes very disturbing. Now, from our perception of light, it moves in 3 dimensions. It has speed and it has intent. It moves from one place to another. With a time dilation of 0, light would have no movement in its own perception. It would essentially be one-dimensional. Using this assumption from light's relative own perception, if speed is distance over time and therefore distance is speed times time, you have, from light's relative perspective in a one-dimensional universe, as a single space-time event, essentially in a point of existence, that speed is 0, time is 0, and the distance is 0. Because from its own perception, once it has reached this relativity at the speed of light, it is one-dimensional. It essentially boils down to a single space-time event. Now, this is kind of, if you've shrunk the whole universe down to one dimension, you only have the capability of representing anything as a single space-time event. Now, you have one probable space-time event, so this is really hard to get your head around. This is the bit that took the most trying to figure out, and it's the bit that doesn't make sense in classical physics. So you have something that leaves an object, is emitted from, say, the sun, travels millions of kilometers, and hits something on the Earth. From our perspective, you can follow it doing it. It takes around 7 minutes. From its perspective, it all happened in a single space-time event. It left the sun and hit the Earth. Now this makes This answers a lot of questions, but it opens a lot more. This is a very odd concept. The relative distance and time have now become zero. So therefore, you are observing an electromagnetic emission. You exist in a one-dimensional universe. Our universe truncated into a single dimensionless point, devoid of time, therefore devoid of distance, therefore devoid of speed. So if you're observing this event from the outside, it's going to show you some very odd paradoxes. This is what I want to come to. The odd paradoxes explain some things in physics, which at the moment are called delayed choice and emission choice. Now, delayed emission choice, if you look at electromagnetic radiation as a single space-time event, isn't delayed anymore, it becomes choice. It also means that it's possible to change the outcome of emission choice. Therefore, theoretically, it could be possible to send information back in time, which seems impossible, but the interaction of space-time, if you can interact with a single event that is the same event now as it was 7 minutes ago, when the photon of light we've been talking about, or the wave of light we've been talking about, has left the sun, you can affect now something that happened 7 minutes ago. And this is the other really interesting part about this theory. As possible proof of this concept, I'd like to look at the delayed choice quantum eraser experiment. This experiment appears to show knowledge has influence over reality. I strongly disagree with this, because if you use the unidimensional theory of light and electromagnetic radiation to examine this experiment, the delayed choice quantum eraser essentially becomes a time or paradox machine, depending on your perception of it. We'll have a quick look at the eraser. I'm going to put it up on the screen. I'm going to go through how the delayed choice quantum eraser is supposed to work, and how I think that, given this theory, shows that it's working in a way that, it's essentially showing you a time travel machine. It's essentially showing you a way of receiving data. So, looking at the diagram, it is a version of the dual slit experiment. There is a laser beam which is fired through a metal plate at two slits. There is then a Glenn-Thompson prism which causes pairs of quanta of light to be entangled. So the red line shows a quanta of light, which is either a wave or a particle, which is coming out from the top slit and is going through the apparatus on the bottom half and going to sensor D0 on the top half after travelling through a lens. The blue lines show the laser that's gone through the bottom slit. That is then travelling to D0, the first sensor, and then is going through the apparatus, also through a prism. Now, what you have here is these BSA, BSD and BSC are essentially going to be like reflectors, mirrors, that you can turn off or on to allow the light through, or not light through, or you can have them just set at 50%. So half the time they let the photons through, half the time they don't. Now, what you will find is that at sensors D1 and D2, both light pathways, the blue and the red, are able to reach the sensor. Now this causes the pattern that appears on D1 and D2 to represent a waveform. So you end up with a wave appearing here, as opposed to a single particle. You get a single particle at D3 and D4. Now, with the quantum eraser experiment, what they discovered was that whatever appears at D1, D2, D3 and D4, because of the quantum entanglement they were observing, also appeared at D0. With the coincidence counter they have there, they were able to discover that whichever form the light took, it would always appear the same at D0 as D2, D4, D3, and D1. Now the trouble with this is that things arrive at D0 first. As you can see quite clearly, the length is less than half the distance. Now, given that light travels exactly the same speed, this entanglement means that what's happened at D0 always matches what happens at D1, D2, D3 and D4, but they always they're happening at different points in time. Now this is why the unidimensional theory of light, I propose that these are a single space-time event. So whether the photons of light are able to interfere with themselves because they have two probable pathways, or whether they have a single pathway, what lands on D1, 2, 3 or 4 and on D0 is the same space-time event. So if something is able to go through, combine with itself, cause its own interference pattern on D2, it'll have the same effect on D0, because from our perception the event on D2 happened after D0, but for D0, for the photon of light on D2 and D0, it's the same space-time event. So it's not a quantum entanglement, it is a single space-time event on D0 and D2, or D0 and D4, or D0 and D1, or D0 and D3. So the coincidence counter would be counting nothing, it would just be matching up the same space-time event. This is why I would prefer to call this the quantum paradox machine. That whatever information you're going to record at D0, even if you record the information before the information is recorded at D2, you will end up with the same information. And at BSC, if you were to remove the bottom half of the machine and just have the sensors D2 and D4, and you just had the mirror A and the mirror B, and you turned BSC into something with an LCD display that you could make completely translucent or allow the light through. Make it translucent or allow the light through. Essentially taking away one of the slits and adding the slit, forcing the result on D2 to be either a wave or a particle. Now, if you had a long enough gap between the apparatus and the emission source, and you got D0 as close as you could essentially send information back in time. If you had, say, 10,000 kilometers to fire the light over, you could send information from D2 back to D0 in the past. You could essentially turn off and on the, shall we say, 50% mirror, turn it off and on, turn it into just LCD screen, just turn it off and on, and send back ones and zeros to D0. Now 10,000 kilometers is only going to give you a quarter of a second, but you would essentially be affecting quarter of a second in the past with your choice at BSC. You would be able to make the choice. You would be able to say wave or particle and record that at D0. But you'd be recording it in the past, creating a paradox. It's a very cool idea. You can turn this quantum eraser into a paradox or a time machine for information. You can send information back if this theory is correct. I'm not saying the theory is correct. I'm saying that it's possible to derive an experiment from this apparatus and apply it to the unidimensional theory of light to test by sending ones and zeros or wave and particle forms back in time from D2 to D0, given enough fiber optic cable or enough clear space line of sight to affect the outcome of an event in the past. And because you could use something known information and you could record it in a separate location, and you would have none of that information at D0 to begin with, you could prove the information had gone back in time with the right equipment. And there's very few theories that are this outlandish, that have this simple way to test it. I mean, it's not simple. The equipment would be astronomical in price and horrendous to put together. I mean, we're dealing with photons of light. You're trying to travel them distances where they'll hit anything, they'll vanish. It would be incredibly difficult to test, but it's nice to have a possibility. It would also mean that distance is irrelevant. Now, this is a difficult concept to come across, but it means that because of the unidimensional theory, that you could say that distance is irrelevant to light. Therefore, you can use this apparatus in another way. You could set this experiment up, fire the two beams of photons, the red and the blue one, into something like a black hole, where they should have a no space-time event, but you'd be able to capture at d0 whether those two potential pathways ever rejoined. You'd be able to scan across by aiming them across the event horizon of a black hole and see what happens to the light, because you'd be able to record it with the Glenn Thompson prism. You'd be able to record what happened to the light at d0, and whatever the apparatus simulation that the black hole came up with, you'd be able to record it, even though this light was not going to reach the black hole for 10 million years or a million years. You'd be able to record there and then the outcome of your experiment that would take 10 million years to happen. You couldn't say for absolute proof what would happen, but the experiment itself would be worth doing. I mean, if the unidimensional theory of light is correct, you can start sending light into space and record what happens to it off of remote objects immediately. That seems insane, but if you collapse down the universe to a single dimension, and you have this single dimension which you can use to send information, you're sending information back in time from wherever the destination is. So if we could record more properties of light on d0 and find other ways of measuring light, we can measure things in the future from the present. And it doesn't sound very likely, but it's a possibility. It's not a given fact. This theory would lead you to the position where you could scan something millions of light years away and have the answer immediately, and all you might be able to scan is where the edge is. But wouldn't that be amazing, to find the actual edge of an event horizon of a black hole by pointing photons of light at it and then seeing when they stopped being a wave and started becoming a particle, because one of them was now sucked over the event horizon and the other one was carrying on straight. So they had no chance of recombining. Maybe you would just never get any result at d0, but that again would tell you something. Maybe you can scan for the location of a planet, because you can tell when something touches, when light touches something. We don't even know if you point this out into the nothingness of space. Would it be possible to find things in front of a black hole, because there would be no space-time event on the black hole? These are all questions that would be fantastic to answer. But I digress. I think that this equipment could be used to prove or disprove this theory. I think that the equipment already, to a certain extent, supports the theory, but I don't think it proves it. I think the idea of a single space-time event for light answers a lot of these questions, like emission choice. That it is an emission choice whether light is a wave or a particle. It is an emission choice whether it's a photon or a massless wave. And it doesn't matter what speed it travels. When light has mass, it still travels at the same speed as when it is an etherical wave. And the single space-time event, with its potential to interact with our universe, can confirm this. And that it's because of that, its potential, it's a single space-time event. So therefore the mass has managed to be transported from one place to another because of the potential of the waveform to get there. And that seems an incredible concept as well. That concept could go a long way to it's a glimmer of a hope of faster than light travel. It is not a way of doing it, but it is a research path. And there is so much that this theory could open up in different aspects of science that we could test in physics, but it just seems so improbable. I'd like to know if this theory is correct or if it's not. At the moment, it's something I spent years researching while I was writing a science fiction novel and studying physics in my spare time. It's not something that I think is 100% accurate, but if it is, it's just opens so many possibilities. But that's why I'm doing this video, is to ask people to get opinion, get talking about it, and maybe somebody can do the quantum eraser as the quantum paradox experiment. To use this, send it back and see if we can prove whether light is a single space-time event. Thank you for watching the video.